welcome to Be Your Own DevOps. This will be an English presentation. Hopefully that's okay. Mostly that's how it was prepared. And yeah, since the crowd is international, we'll kind of keep it like this. So also, if you have any questions, feel free to leave them in the Q&A section. I'll answer them as quick as I can. I'll try to check the section during the presentation. If that doesn't work out, we'll do all of them at the end. There's no problem with that. As for this presentation, the title is kind of obvious as for its topic, but you might ask yourself why. Like, why would you do this? Why be your own DevOps? And for that, we'll talk a bit about the motivation behind all of this, after which we'll take a look onto how it can help you become a better developer overall, and we'll end by discussing how you can do it. And yeah, at the end, all of the learning resources will be available on my GitHub profile. It's in the pinned gist, so you won't miss it, even if you missed a screenshot during the presentation. Okay, so let's start, as discussed, with the motivation behind all of this, with a bit of a story time. During the last couple of years, I found quite a lot of people who do their best to stay as far away from DevOps as possible. Most of them doing it because of an innate fear of low-level programming. As well, I didn't know exactly where this wrongful association between low-level programming and DevOps came from. But if you think of it, I have noticed it start while I was still in college. There, I started noticing colleagues drifting away from this dark side of software engineering after they began working with 86 assembly and C++ under Linux. And since school tends to be very theoretical and not quite fun, most of my former colleagues started associating Linux with that scary unknown that they had to make sense before the final exams. And yeah, since most servers in this world run on Linux, and DevOps tends to get its hands dirty sometimes with the depths of the underlying operating system, sometimes in quotation marks, you see why in the end. DevOps and Linux became quite a relationship. Even though, as you'll see in the presentation, Linux is just a small part of DevOps engineer workload. And while some of them were interested in low-level programming language and loved this, the vast majority started feeling Linux and everything associated with it. This pattern showed itself even more when I began working with self-taught developers who did not have this kind of exposure mentioned previously. Most of them were curious to try it out and found it quite fun, some even considering a career change. Being one of the odd bunch who embraced the dark side, if you're to call it like that, I will try and show you why being your own light DevOps is not as difficult as you might think, nor does it involve a lot of low-level programming. Moreover, it can be quite fun and rewarding, while benefiting you both professionally and out of hours. So, what is it? Right? What's DevOps? First, let's clarify a bit that DevOps is a process, not necessarily a job. The title is as such because, yeah, it makes it appear to broader audiences, since DevOps is frequently used to describe tasks related to building automation, continuous integration, continuous delivery, and so on. However, one good term about DevOps would be like the one pioneered by Google, calling it site reliability engineering. At the base level, this refers to a software engineers who applies software engineering principles, like you do in programming, to operations and infrastructure problems. The end goal being to create reliable systems. Actually, this confusing terminology is one of the things that contribute to the obscurity surrounding this field. Let's take a look at the origin first and see how it works. As said, DevOps is a set of practices, right? A software that combines software development, hence the dev part, and IT operations, hence the ops part. Its aim is to shorten the software development lifecycle by providing continuous delivery with high software quality. In a nutshell, faster releases and better quality of said releases. Here's the short version of a pipeline, for example. You have the build phase, right, where you compile the code, followed by a test phase, when you check the quality of the code through various methods. You do that as a developer as well, like unit testing, integration testing, static code analysis. And after we release the product, here's the continuous delivery part of the equation, right? And as example, if you can think of taking the compiled application and deploying it to a server, to production, or someplace where clients can use it. That's done either using various scripts and tools like Ansible, or through Docker containers, or through serverless cloud services like AWS Lambda, and so on. After this software is deployed, you move to the operation sides of the DevOps, where you have to place the infrastructure to have the infrastructure in place to monitor running services, right? Think of tools like, I don't know, Datadog, Grafana, Kibana, Splunk, pick your poison there. And you use that data, that monitor data, to plan for future releases. And then the cycle continues. This is quite a quick overview of the DevOps process, something that most likely you're all doing in one way or another, as it's part of the software development lifecycle. But here comes DevSecOps, right? Or SecDevOps, we'll get into that. This just adds application security in the mix, like scanning, analyzing vulnerabilities, remediating and monitoring issues, and doing active threat management. And funny enough, SecDevOps is actually a term as well. That's basically DevSecOps, where you're making every decision a security-first decision. Yeah, and there is GitOps, which is a deployment methodology centered around the Git repository. Here, yeah, any code merged into a Git repo triggers a deployment to various environments in real time. And I guess this sounds quite familiar. Well, since Git is a familiar tool in the developer community, GitOps is touted as the developer-centric deployment strategy. But funny enough, most DevOps projects are actually doing GitOps, and we all care about security as well. So we're kind of GitOps, you get the point, right? There are so many terms for the engineer that automates stuff that everything gets complicated. And in the end, I don't know, just call it DevOps, right? Proper DevOps, just like you're not doing Git Java if you're a Java developer working on Git projects, or sec.net if you're working security in .NET. And yeah, right now I think most of you should be called dev Gits or Git devs, since developers work mostly on Git right now. So now that this is clarified, why? Why would you want to learn DevOps practices? I mean, are there not people assigned to do that job? Would it help me in my career if I did that myself? Would it help me outside work? And would it not take away my precious time? Well, the answer to those questions are more or less yes. Yes, and definitely no. Starting with the first one, yeah, DevOps engineers are assigned to do infrastructure work, but that's not necessarily the same thing as fixing file not found errors. System engineering departments are maintaining critical business as usual infrastructure, so their time is very valuable there, making things very easy for everyone in the long run. Besides that, your time is precious too, and you don't want to wait hours for someone else to come and fix a trivial problem that you could solve in a couple of minutes, right? But do you need it though? I mean, why would you need to know all of that if you're a Java guru or a web genius? Well, you might be a master in any programming language. Like Jen Gosling might have a picture of you on his wall, and it will not matter, because in the end, you need to deploy that said code you wrote somewhere. And yeah, these are my GIMP skills right here for the world to see. So now I think I can add UI UX to my CV. Moving on, besides helping you deploy your work, knowing how to interact with a server and how IT infrastructure works in general, and yeah, how services communicate between themselves, it will give you a greater understanding of computing in general. this is one of the differences between developers and system architects, principal engineers, consultants, and so on. But what about your day-to-day life? I mean, I had that mentioned in the presentation description, and it might have seemed a bit odd. Would it help you outside your work? Well, it depends on what kind of help you want. For example, home automation might help you since it will create a more present environment for you to live in. Let me show you a great example of how that helped me. A while ago, I decided to follow the smarty dandy housey thingies trend and bought myself some light bulbs and some smart plugs. Small off topic here, I actually had no idea how many quirky things you can do with a light bulb. It's wonderful. And yeah, now the vendor does an awesome job on the management application for Android and iOS. However, I kind of wanted to control everything from a web interface as well, or actually use Siri to give it commands and stuff like that. Yeah, and a web interface which actually they don't provide. Now, fortunately, they are smart and kind enough to expose their configuration API endpoints for their products. That's great. I mean, you can use a web application to interact with that, right? And there are plenty of those online. But wait a second. That's a bit problematic because you need to host that somewhere. And in that case, you need to keep your computer running like 24/7 for that. That's not very efficient, especially considering current electricity prices. I think your wallet won't love you after this one, that's for sure. But we all know of something called a Raspberry Pi, but that runs Linux with packages, systemd, and all of that. So you need some basic Linux knowledge to make it work. Luckily, if you have that at a bare minimum, to a point where you can basically follow online guides, nothing more than that, you can handle this problem pretty easily. And for example, I was not only able to deploy a free web app to manage my devices and track electricity costs, but also to install an NPM package called Homebridge, which is a very cool piece of software. It basically allows you to register any device as a Apple HomeKit one. So it enables Siri interaction with them, and that's needed because Siri does not work with unsupported third-party devices by default. Yeah, thanks Apple for that. So in the broad side, that's how it can help you outside work in your everyday life. And there are many more tools, self-hosted tools that are simply awesome. I mean, you have Nextcloud, which is a self-hosted storage server for everything you need to store, basically, from photos, videos. It even does integration with Word and various document management tools. And yeah, it has great apps and third-party integrations. There is also Pi-hole, which is a network-wide ad blocker and privacy enhancer. And besides, you also got innate, and that's a workflow automation tool for anything you can think of. Like, I don't know, when I come home and yeah, you detect me in proximity of a certain sensor, like lit all the light bulbs and play some music and send an email to someone. And you can basically link everything from email, Spotify, GitHub repos, Facebook, whatever with it. And yeah, it's graphical as well, which is also nice. You don't need to write any code for it. And another example is Bitwarden, which is an amazing self-hosted password manager. And there are many more tools like this. And yeah, as said in the beginning, there will be links at the end of the presentation for some great resources and communities on this topic, which are also in a gist pinned on my GitHub profile. So feel free to check that out and even reach out to me for more. But now you might think to yourself, those are some fair points, but sure you're not as busy as I am. I mean, if you care about your time, you won't bother learning about and doing stuff that you're not supposed to do, right? I mean, you're not paid for that. However, if you think of that for a second, Would you prefer to ask someone else about trivialities, like wait a half an hour for him to be available, wait another half an hour for him to get some context about your issue and solve it? Or would you rather know how to fix it yourself in like 5 minutes or Google a solution for it? I had something similar happening to me when I was working in engineering enhancements for our e-commerce solutions department. I've been asked about being unable to create a directory using this command right here. And obviously, for those who have run something like this, you might guess that it failed because the first directory was not created. My colleague told me at first, hey, I cannot create a directory on this machine. So I went in, tried to, and it worked. Then I replied to him. After that, he called me, we had a quick chat in which he told me what command he ran, and then I figured it out. And that was like 10-15 minutes of talking, tasks, switching, confusion, all of that for something that it could have been fixed on the spot with some basic Linux operations and or by doing a quick Google search on it. So yeah, don't forget Linux is user-friendly, it's just very picky about its friends. For real though, basic Linux operations are very easy to learn and they have very good benefits to learning time ratios. And funny enough, the thing that happened was not the developer's fault, actually. In many organizations, there is a sort of a separation between engineers and their type of work. And while I'm not a fan of the full stack concept, I do believe that knowing a tiny bit of everything will help you and the company in the long run. So another example when this could have worked in your favor is when you have to do some repetitive monkey work on a project, right? We will have to do this sometimes, and it's quite frustrating. It's tedious, it's repetitive, it makes you think like, okay, so I've learned all of this expert programming stuff just to do something that a 12-year-old can do as well. However, you can fix that pretty easily by writing a script. Yeah, so first time I got burned by this was when I started my development journey and I've been asked to do some basic Postman requests using a list of UIDs, like I think 30 of them. And this was back then where Postman was the new greatest thing on earth. So yeah, and me being a bit, let's call it pragmatic, since rash or lazy does not sound that good, I decided to do everything manually because yeah, it does not sound like that much of work to do. And yeah, after a couple of minutes, I've done the request, notified my colleagues, and then got an oopsie as a reply. Turns out they forgot about something, and I had to do it again for like 2 more environments. Okay, let's do it. Manual work again. In the end, I come back, all good. Everything works fine, went on to another task. Just to find out the next day that our client wanted around 400 UIDs propagated to all of these environments. Well, that's a bit too much to do manually. So I went in, wrote a script, which took me like 5 minutes actually, and did this for as many UIDs as you want to, on as many environments as you want to. And the script is also quite easy to run to write and run because it's Python. So yeah, quite an okay language to do that. And since then, I kind of try to script everything that's repetitive, so writing scripts to do certain tasks for you makes those tasks boss-proof, you could call it like that, meaning that you could easily regenerate those results if the specs change. So don't just learn how to code, learn to automate. This is why you should invest in yourself, firstly, because it's not about wasting someone else's time. It's also about wasting yours as well. So let's talk a bit about opportunity now. Because by learning new skills, you become a bit more valuable as a developer. And this broadens your options, right, in the market. So because you're wanted more around the world. And because knowing a bit of how applications are deployed and how servers work, this will, as said earlier, will turn you from a developer into someone with greater knowledge about the whole development lifecycle. And you'll be able to understand end-to-end delivery of certain products, and that's extremely valuable, right? Because it opens you up to a list of potential issues that might appear on the delivery side, and those will impact your application at some point. And yeah, you'll have a better understanding of how scaling works, how network bottleneck might affect performance of your services, and many more like this. And knowing stuff like this in advance allows you to plan ahead and avoid certain hops while you're still in planning and or the development stage. So, okay, I think this is thinking for a bit, but how do you do it? Okay, so let's look a bit about on resources right now. First of all, there is a pretty good roadmap online, and this is the link right here. I'll go a bit more in depth on some tools that are here that I think you might benefit as developers. This roadmap is mostly for DevOps engineers, wannabes, like people who want to become DevOps engineers or who are working on that per career path. So you won't necessarily need most of the tools that are there listed, but some of them might come in handy for you. So let's start with the cool thing that you've most likely used or heard of, which is Docker, right? And actually containers overall. So why do people use containers, right? Why not virtual machines? Well, for one, they are kind of lightweight compared to virtual machines because you're not hosting the entire operating system on them, right? You could find containers like Alpine Linux, which takes 5 megabytes as opposed to a virtual machine that can use gigabytes of disk space. And besides that, you're also getting better performance due to bypassing the guest operating system. And these advantages allow us to virtualize applications instead of operating systems, which result in better isolation and control for each service. This makes them much easier to move around and deploy them, hence all the buzz about microservices. You can also test your applications much easily on a local development environment. Imagine if you have to install like everything on a virtual machine from a database, and you have to set all of that out. And also, if you think of integration tests, right, and something like this, you'll have to spun up an entire database. That's a bit annoying. Right now, we know that there are various scripting tools and project management tools like Maven, which you can get certain plugins to start a Docker container of MySQL for you right away. And yeah, but now after all of this innovation, we have lots of containers and bad things might happen. So we need a way to coordinate the way they work together. Think of services like an orchestra, right? Where instruments work together to create a masterpiece. If one of them goes wrong, everything kind of crumbles around it. So for that, you need some container orchestration tools, which automates all of this operational effort required to containerize workloads and services. It does this by managing the container life cycles, like when does a container stop and where does it run and stuff like this. Networking between them, load balancing, and many more. So now let's look a bit on some resources on this topic. So where do you start? There is this nice getting started article about Docker, if you're not familiar with it already, at dockercurriculum.com. This will walk you through how Docker containers work and how you can create and run your own containers. So, however, if you're looking for a more in-depth view, I highly recommend Maximilian's course on the Udemy, the Docker and Kubernetes Practical Guide, and Mamshad's course as well if you're looking for a Kubernetes certification, like Certified Kubernetes Administrator. But as a free alternative, there are also quite good channels on YouTube, like the freecodingcamp.org channel, which has lots of videos on a wide area of topics, including Docker and Kubernetes. As mentioned before, all of this will be listed after the presentation, so you can get started right away. And for self-hosted projects like Nextcloud and home automation, you have this awesome self-hosted repository on GitHub, which basically links you to thousands of tools you can self-host at home. And it also gives you a tiny small description of what each and every one of those does, if that's a free tool or not. And if you have any issues with that, there is a great community on Reddit, which can help you fixing various issues you might encounter along the way. And as for Linux, there are linuxjourney.com and two more similar websites like Linux Survivor and Linux Command. They are all offering interactive guides to Linux and various stuff like networking, command line. My pick from all of this would be Linux Journey, since it's the more modern variant. It looks something like this. So this is just the first chapter, which is the one I recommend for beginners. It will get you up to speed with everything you need for doing day-to-day tasks from a development perspective. So yeah, basically it will explain you what Linux is, then it will give you some basics about the command line and some basic navigation commands, text manipulation, user management and permissions if you're having those I don't know, not necessarily find not found, but the not authorized errors. Yeah, and how processes and packages are run and installed on Linux. And a few more like these. So the Open Guide to Amazon Web Services, for those interested in cloud technologies, it's quite an awesome compilation of small guides, small walkthroughs for basically every service that Amazon offers, which are quite a lot. I don't know exactly if there is something like this for AWS, for Azure and Google Cloud. I'm pretty sure there is. But this is one link you might want to bookmark, especially if you're working in cloud, in a cloud environment. Because yeah, when you have to use something, I don't know, like Elastic Beanstalk for the first time, you can just go there and get a high-level overview of the technology and a small guide of how to get started on it. There is also computer networking, a top-down approach from Curious Ross, and that's for you if you want to learn basically how the internet works, right? So from how various servers connect to one another, from, I don't know, how the OSI layer stacks up. That's the way we represent communications. You can think of it the passing of data through, starting from the physical layer, having the copper wires which transfer the electricity through it. And yeah, then for data links, switches, routers above, and so on. And if you want to learn all of that, that's a pretty good course. And if you want to automate boring stuff with Python, we have Automating the Boring Stuff with Python, which is also quite a good book. It gets you started on Python quite easily, and yeah, you'll find out that with Python you can kind of integrate it everywhere and use it for anything, including stuff like home automation. You can write like 3 lines and automate something that you want. And I just leave this for a bit. And also, if you'll also be able to find all of this in the Pinterest, as stated earlier. Yeah, this went a bit fast because yeah, this is the end. So I hope you enjoyed this presentation. As you saw in the presentation summary, I'm Bogdan. I'm a principal engineer in Nagaro. I've also co-founded a pretty cool startup called Rabian Labs, and in my spare time, as said, we're doing volunteer work at iCare, an animal rescue NGO based in Cluj-Napoca. So if you're interested in fostering or adopting an animal, feel free to search and reach out to us on our Facebook page. And
thank you, Bogdan. Now I would like to invite the audience to ask some questions for Bogdan. I mean, one piece of advice for the organizer, I have to say that next time I would start the DevOps track together with Bogdan's presentation. Why? Because it's very, it is, I have felt actually that you are teaching courses and you have a very, let's say, pedagogical background onto that due to the way of explaining every its and bits of the DevOps. And I mean, even from the managerial point of view, because if I would take into account all the advices based on which I should recruit people in my DevOps team, maybe 99% of the criteria you already have covered. Now we have the first question from Anda. What was the most challenging part about setting up your smart home solution?
Yeah, this was quite a journey because especially when you're living with someone, you have to make it quite error-proof. Let's put it like that. Especially when, So if you want to set something up, you kind of need to set it up properly, because if not, it will cause quite a lot of issues when when you need it the most. That's the moment it fails. So I went through a lot of trials and errors at first. I think I started it quite a while ago, like 4 or 5 years ago, and it's a bit. It's a bit interesting because when I started it, kind of everything failed for a while, and then I looked a bit into resiliency, right, and having everything deployed in two places and replicas of each other. I think one of the problems with starting up is that it will require a bit of capital at first, and if I'm to recommend something right now is to not chip out, because I've ended up actually having to replace the cheaper thing that I got to, and in the end, I had to buy the more expensive solution because it was the resilient one. That goes for home routers, for light bulbs. I tried with cheap ones at first, and they failed on me. They started quite hard. You have to program them to do. It was quite hard to program them to do certain stuff. And when I moved to Philips Hue and that ecosystem, everything just works. Same goes with the internet solutions. Like first I tried with a lot of cheaper alternatives for routers and switches, where you could get your hands dirty and you have to configure everything by hand using a proprietary language. And of course, you're kind of prone to failure by then. And when everything kind of started crumbling, I was like, okay, kind of need to make a bigger investment in this and have things work out properly, because you have knowledge about that. Let's say if you have some Linux experience as well, but there's also the device part there, where no matter how you set it up, it might fail just because it's a crappy product.
Thank you, Bogdan. Any other questions from the audience? Until we are receiving here, I have prepared some couple of questions for you. If I'm passionate about IT, but not from the operational point of view, I mean, I like developing, but this type of the maintenance infrastructure stuff is not the. Can I still become an engineer in DevOps?
Well, you can. So DevOps, it's a bit funny because it covers a wide area of topics, just like I shown in the presentation before. Actually, just for the Docker and Kubernetes side of things, I think there is a landscape online. If you Google landscape Cloud Native Computing Foundation, you'll get to a site where you can see like hundreds, if not thousands of tools listed out there just for those technologies alone. So the thing is that with DevOps, we're often sort of jack of all trades, master of none, let's say. And I will argue that if you feel like that, like you want to know a bit of this and know a bit of that, and have knowledge on many topics, but not necessarily become an expert onto something. This is like a pretty good job for that. There is also another thing we need a bit of development as well in DevOps, because while you're not developing tools most of the time because you're using stuff that's already made, it helps a lot if you have a background in development and you know how products get from the source code to having the client actually using them. Because as a DevOps, you have to maintain all that pipeline, test the application, deploy it, monitor it, and so on. So if you have knowledge of the development process, it will help you quite a lot. And yeah, development also helps you when you write continuous integration pipeline, when you write scripts. So actually, in Jenkins, continuous integration pipelines are written in Groovy, which is sort of like Java. You can also write it directly in Java. So if you're a Java developer, you can write your own right away, I would say.
Mihaela is asking you if you can tell us a few essential skills for DevOps engineer and some most common challenges that you have faced so far.
So I can touch on this one mostly because right now we have also done a DevOps internship, which is this summer, and I got to see how people that are kind of new to this part of development interact with various tools. I would say a bit on the essentials list is knowing a programming language quite okay. Doesn't matter necessarily if it's Java, Python, Golang, .NET, JavaScript. So just one of them, know it well, because that will translate to other languages quite easy. And you also need to have some basic Linux knowledge. And yeah, from that, I would say most stuff gets learned in sort of an internship program or as a junior. If you want to start from zero and get hired, bypass all of that internship stuff, what you need to know, I think it's basic scripting, right, and the programming language, Linux, some basic Linux, basic networking. Containers are a must right now, and if you know how to work around a cloud environment like AWS and tool like Jenkins for continuous integration, that should be enough.
I know that usually due to the, let's say, lack of resources, recently these types of internships are developed more and more frequently within the multinational companies, because it's a way of forming new engineers into that. And I think it's a tremendous value added both for the company, but also for the person itself. So sometimes, as you can see, constraints on resources are also useful.
Yeah, and quite an interesting thing, because now I got to me the second part of the question, the most common challenges. I think the most common one would actually be the lack of resources, because if you want to learn certain tools like playing with, I don't know, Terraform and developing being in the cloud environment, it's quite hard to do it for free, because you cannot create a lot of virtual machines and servers and deployments on AWS, because that costs a lot of money. So that's why we're also doing these DevOps internships, because there you can play with them. Since DevOps is not that taught in schools actually at all, it's very hard to find students, I would say.
Mihaly is asking you if you implemented some kind of automation which involved new version development of a relational database, and which tool did you use?
So are we talking about, let's say you have sort of an Oracle instance, like an old Oracle instance, and you want to deploy like Oracle 11 and you want to move to 19 or to the latest one? Because I think in that case, it depends where it's installed. Yeah. It depends where it's installed, because if you're using, of course, if you're using a cloud, a serverless cloud hosting like RDS or even Oracle Cloud for it, you can quite easily migrate the data and upgrade the version using Terraform or just using tools that the cloud provider has. But if you're hosting it yourself, that's a bit more complicated, especially if you're doing, I don't know, clusters of it. In that case, what we've done at some point, there were some Ansible playbooks. Ansible, it's basically a tool where you tell it, okay, I want this software to be installed on that machine, and it just connects to that machine and installs that software for you, or runs a certain script, or creates directories and so on, whatever you ask him to do. And using that, we'll have various playbooks that connect to the server, shut down the old instance, create a new one, migrate the data, and stuff like this. With Oracle, I know it's quite painful, but the pain with it, I see it's more for a development standpoint, because unless you have some tools like I have an issue remembering it right now, but there are some tools, especially for Java, for example, where it keeps track of the schema from one version of the application to another, and then the thing that you do when you create a new database, you just run that tool and it creates the whole schema right away and you start migrating. But if you don't have that, it's a bit complicated. But again, from a development perspective, mostly from DevOps, you just shut it down, move the data, and
or something like this on versioning. Let's see. Andre is asking you also if any suggestion regarding service level agreements or service level operations. Actually, how do you establish them and how to track them?
Yep. So first of all, you're welcome, Mihaly. And with regards to the Andre's question, you can do monitoring for availability mostly, and various other SLA topics, let's call it like that, metrics, like I know response time and performance. You can use tools like, I think even Prometheus has some, for availability, it has something called the black box exporter, which regularly pings the website to see if it's still up and running. If you want, you can configure how often it pings it, and you also have various tools that check for availability online. I think even Splunk has some integrations like that. Or as I seen on one project, there was a tiny application developed that you actually have it on a server and you need to just send metrics regularly, like as quick as it can to a server, like heartbeats, just to let that know that it's up and running. So there are various ways of doing it. I would recommend something like, I don't know, Prometheus, Datadog, and for performance, that's a bit more complicated. For SLAs, I think we had something on the project, but I'm trying to remember it. It was like 6 years ago. Again, it was sort of a tool like Gatling or something like this that does load testing, and we have configured it to keep testing the application and and collect all the data into a Splunk dashboard where it will show like, okay, it takes an average of X milliseconds to load this page and stuff like this. You could look into that direction, I think.
Thank you. Any other questions from the audience? We still have more than 10 minutes together with us with Bogdan before moving again to the main track. So my advice, profit. Take advantage of this presence here. Because I will move to management questions. Bogdan, first of all, did you have a management position within DevOps? Like having teams?
Yes, I'm actually doing that right now, but with DevOps is a bit complicated when it comes to managing people, because unless you have a huge project that is only DevOps oriented, let's say you're providing cloud services for a client, and you have to be there to deploy a lot of stuff and in Amazon and whatever, then you might have a team of DevOps. But in most cases, we kind of work on multiple projects at a time, or you're not really seeing a team of DevOps on a single project. And once most of the stuff are automated, I tend to think of that like when the developer does a commit, pushes it to a repository, and from that point everything happens automatically, including the testing, the deployment of certain environment, and so on, and monitoring with alerting and so on. Once all of that is into place, you've kind of done your job quite well there. And you can just get into maintenance mode and move to other projects. So it's quite common to have DevOps spread out in a company on multiple projects. What we're doing in Nagaro, so for my project, we actually have a team of DevOps engineers because it's quite a huge project. And along with a colleague, we were also mentoring a team of students, of 4 students that have participated in our internship and now are juniors in the company.
Because my questions actually is referring to the, let's say, to the factors that are making a DevOps team to function really, really well. But somehow you have answered also. But what is interesting from your answer is actually that the component of the operations from the DevOps part, most of them are automated.
Yeah, they should be actually. So you need to have alerting and stuff like this in place. You know, it's interesting because it kind of rewards you for being lazy if you put it like this.
You told us and I didn't.
Yeah, so you need to look out for, I don't know, for finding ways to be lazy, but in a good way. So not in, I don't know, not implementing something because it will work anyway, but in the way in which you try to automate everything so that it does not need you anymore there.
To transform it into a positive efficiency. Let's
exactly.
Put it on.
Yeah.
More diplomatic. Well, any other questions for Bogdan? Well, it seems that that was all from the DevOps track. Thank you, Bogdan. Thank you for taking your time to be today with us here.